Welcome to Basic Chemistry. Today discussing Plus 1 Chemistry, Unit 13, Hydrocarbon. Hydrocarbon means compounds of carbon and hydrogen. Hydrocarbons play a key role in our daily life. You must be familiar with the term Lpg, Cng and Lng. Lpg means liquefied petroleum gas and Cng stands for C, that means compressed natural gas. What is LNG? LNG is a liquefied natural gas and these also fuels is obtained by liquefaction of natural gas. Petrol, diesel and kerosene oil are obtained by the fractional distillation of petroleum that found under the earth's crust. Coal gas is obtained by the destructive distillation of coal and natural gas is found in upper strata during drilling of oil wells. The gas after compression is known as compressed natural gas. LPG is used as a domestic fuel with the least pollution and kerosene oil also used as a domestic fuel, but it causes some pollution. Automobiles needed fuels like petrol, diesel and CNG. Petrol and CNG operated automobile cause less pollution. All these fuels contain mixture of hydrocarbons which are source of energy. So let's be discussing more about this chapter. Hydrocarbons are classified into three categories. First one is saturated hydrocarbon. And second is unsaturated hydrocarbon. And third is aromatic hydrocarbon. Saturated hydrocarbon contain carbon-carbon single bond and carbon-hydrogen single bond. If different carbon atoms are joined together with a single bond and they are termed as alkane. Alkanes. Simply the general formula of alkane is CnH2n plus 2. CnH2n plus 2. So this is saturated hydrocarbons. All the hydrogen will be single bonded. Unsaturated hydrocarbon contain carbon-carbon multiple bond, that is carbon-carbon double bond and carbon-carbon triple bond. And double bond, that means it is alkene, ALKENE, and triple bond, that is alkyne, ALKYNE. That is alkene and alkyne. That is known as unsaturated hydrocarbons. Aromatic hydrocarbons are special type of cyclic compound. Example, benzene. This is an aromatic hydrocarbon. So we are discussing more in the chapter. So we are discussing alkanes. Alkane, ALKAENES, alkanes. So alkanes, that is saturated open chain, that is straight chain, open chain, CCC single bond or C hydrogen that bond, saturated open chain carbon single bond, carbon single bonds. So example one will be CH4, that is methane. So methane is the first member of this family. Methane is a member of this family and methane is also found in coal mines and marshy place. If you replace one hydrogen atom from methane using carbon atom, you can join the required number of hydrogen to satisfy the tetravalency. How can you write this? C H, once again I write C carbon, H, one of the hydrogen is replaced by other carbon atom. So that due to the satisfying tetravalency, we can write the other hydrogen atom. So here 3 hydrogen atom also right. So we get CH3 single bond CH3. So the number of carbon atom will be 2. So the name is ethyne. So the name is represented as ethyne. ETHANE, ethyne. So can be general formula as CnH2n plus 2, therefore CnH2n plus 2. So here C2 carbon number is 1, 2, so we can write as C2 2 into 2 plus 2, that is 4 plus 2, that is 6, C2H6, that is ethyne. So we can add more number of carbon atom by replacing one hydrogen atom, and we get different alkanes. So in alkane, the first carbon atom, the formation of the compound is methane, and the second C2 we get C2H6, and third carbon atom will be C3. So we get C3H8, and fourth one is C4H10 respectively. So there will be a difference, will be the CH2 difference here, that's a CH4 and C2H6 and C3H8 and C4H10. The neighboring groups are differ from that's by CH2 group. So this is according to the formula. We can write the general formula alkanes, how it is obtained using by homologous series. What is homologous series? That means homologous series. Homologous series. So what is homologous series? Homologous series. Homologous series is simply a series. Homologous series simply a series and of compounds. A series of a compound in which the molecular formula of a compound differs from those of its neighboring compounds by the CH2 group. That is known as homologous series. Okay. Then the methane compounds, methane atom CH4, that is methane. According to VSEPR theory, methane is a tetrahedral structure, and which is multiplanar, in which a carbon atom lies at the center and the 4 hydrogen atom lie at the 4 corner. So we can write represent it as like C, and we can write this way, and hydrogen atom lie at the 4 corner. Hydrogen atom lies 4 corner like this. So we get this is the structure of methane, CH4. This is structure of methane, and all HCH bond angles are 109.5 degree. 109.5 degree. In alkanes, tetrahedra are joined together in which CC and CH bonds are 154 picometer and 112 picometer respectively. This is a structure of methane, CH4. This is a tetrahedral structure. Let's discussing nomenclature and isomerism. Nomenclature. So International Union of Pure and Applied Chemistry is used as a nomenclature of alkane. Simply, how can you represent the nomenclature for alkane? Alkane, alkane, the general formula of alkane is CnH2n plus 2. After that we can write according to this carbon numbers. We get standard form, that is C1 is represented as a meth, and the C2 number of carbon 2, that is ether, and C3 proper, C4 is bute, and C5 stands for pent, C6 stands for hex, C7 is hept, C8 is oct, C9, the carbon number 9 is non, and C10 this dec. So you must study the number of carbon atom using IUPAC nomenclature representation. It will help you to find out the nomenclature also. So I will give you an example. So C4H10. C4H10 means, what is that? C4H10. Carbon number is 4. So there is a 4 number of carbon atom. 4 carbon is single bonded. So according to alkane, so you know CnH2n plus 2. Applying these rules, we get C4 and H4 into 2 plus 2. You get C4H10. So you must understand that this is a compound name is butane. So you can write or represent the structure. By representing the structure, you must draw 4 carbon atom with a single bond, C, 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 and you should write the numbers on each carbon atom, 1, 2, 3, 4, and the next you should write the hydrogen atom, that is the first carbon containing 3 hydrogen only, so you write this, and second carbon only satisfy the 2 hydrogen atom. So here 2 hydrogen, the next also 2 hydrogen, because already 2 bonds are here. The valency of carbon is 4. The fourth carbon atom is want 3 hydrogen to satisfy the valency. So here is the butane. So here is a butane. So otherwise we can call it as a N-butane, that is normal structure. This is an open chain structure of butane. So next I will give other examples. 2-methyl propane. 2-methyl propane. You know 2-methyl propane, the main chain is propane. Propane, that is simple alkane. Propane is simple alkane. You can write or you can draw single bonded 3 carbon atom, that is C, C and C, that is main chain is propane. So you can write like this, and they given as 2-methyl, that is this is a branched group. You must think that is a main chain and this is a branched chain. So the number of carbon is 2. They given the 2-methyl stands for the branch, it's is in 2. The second carbon have branch. So first of all you write the 3 carbon separate single with a single bonded, and you should write the numbers 1, 2, 3, and the second carbon containing 1 methyl group. So you should remember that methyl. So I will give you the methyl means 1 hydrogen is missing from that alkane compound. So methyl we can write it as CH3 bond. This is methyl. Methyl means in alkane one of hydrogen is missing or 1 hydrogen is replaced, that is alkyl form. So in this example methyl is CH3. So it will be added in this branch, second carbon atom. So we get CH3. So this is methyl group. I will discussing later alkyl group. So you can write this hydrogen atom CH. Here also 1 bonded. So satisfying this carbon tetravalency, you get added the 3 hydrogen atom. And in second carbon already 3 bonds are there. So 1 hydrogen you must add it. And in third carbon you should add it 3 hydrogen only. So this is this 2-methyl. 2 stands for the branched carbon. That is the second carbon having a one branch, that is methyl. And propane is a stands for what is that? Propane is a main chain. So 3 carbon, 1, 2, 3. Second carbon contain one of the branch, that is methyl, and this is satisfying 2-methyl propane. Otherwise we can call it as an isobutane. Isobutane. So this is a IUPAC nomenclature, and isobutane is a common name we can use to. Other examples, that is pentane. Pentane. So you must write carbon number will be 5. So pen stands for 5 carbon. So C, 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 C. That is, should write the numbers also 1, 2, 3, 4, 5. So then next stage you can add hydrogen atom by satisfying the tetravalency. You can add hydrogen 1, here also hydrogen, here also hydrogen. And the second carbon contain double bond, the bonds are, 2 bonds are there, so you must add 2 hydrogen here. And this third carbon atom also 2 hydrogen, and fourth one also 2 hydrogen, and fifth one is also 3 hydrogen. So this is a pentane, or otherwise we can also normal pentane, that is N-pentane, N-pentane. So this is also N-pentane. So how can you find out 2-methyl butane, 2-methyl pentane, like that? So you just do it for homework. Okay. Then next class we are discussing isomerism and IUPAC nomenclature, and with other compounds, and also other examples, and we will discussing the preparation of alkane and chemical properties, physical properties of alkane, and after that alkane, alkyne, and lastly aromatic hydrocarbons. Okay, thank you.